let's look at SaveGame and LoadGame. So here, this is already done in the structured version. So let's have a look at the structured version of the code. So structured version, there is a SaveGame somewhere. SaveGame here, 12. So this takes a bunch of parameters. So the various items on the game board, and probably the monster position. I was going to say the game board itself, but no, just the positions. And we use this current game data variable here, which is of type game data. Let's have a quick look at that. Game data is a structure, so it's got some. It's a structure, and it contains these cell references: trap positions, monster, player, etc. And if you remember, this cell reference is also a structure just here. Okay, so we use the game data structure to save. To collate all the various cell references together. Move down there. Put them all into this one structure, and then write it to the output file. Okay, and then we use the file put to sort of create a binary file to and export this all as a binary. Dump this structure here, the sort of binary details, into the file, and then the load reads the file into a variable of type game data structure, and then sets the various entity positions and passes them back into the play subroutine. Passes them back by using the byref qualifier here for these parameters. Okay, so load game, save game, and we leverage this. We create this new structure called game data. So let's have a look at what changes are needed. So let's go down and first of all think about object-oriented programming. So I have created two new methods within the game class. So a game can load itself from a file, and a game can save itself to a file. So this public method save and this public method load are within the game class. So if I go to game class, where's the header? Game class. Okay, so I've created a load and a save method. I have also created this structure within the game class. I don't need it outside of the game class, so I've just put it in there. What else have I done? Let's have a quick look at the save first of all. So here, notice we don't need to pass in any parameters because the save method, being a method within the game class, has access to all of the private attributes within the class. And those private attributes include trap position, well, trap 1, trap 2, player, flask, cavern, and one or two others. We can have a very quick scoot up and look at the constructor. Well, we don't need to look at the constructor actually, do we? Because in VB we declare these the variables that we want to use. So these classes, these classes will be instantiated at runtime to give us these objects. And so these are these private attributes, these objects are going to be available to all methods. So save can come along and say, right, let's interrogate the player object. Go down to my save again, down here. So I can interrogate it, the player position, let's say, by doing a dot get position. So in other words, I'm invoking or running the method get position, this object's method get position, and that returns, we can have a look, it returns a cell reference. And in the OOP version we could have probably made it a class, but I think in the OOP version we're still using it, the structure. So that's the structure there. Okay, so this returns a cell reference structure, which we then set to trap position 1 in this game data variable. And game data itself, if we have a remind ourselves, if I no, can I go up there by function 12? So we can see it. We've seen this already, haven't we? That this these positions are held within these variables within the game data structure, and they all have these type cell reference, and we've got this monster awake as well. Okay, so the key thing is to remember we don't need to pass in any parameters. So we create the current game data variable to get all the positions, which we can then use to write out to the file with the file put, just as we did in the structured version. But we can get the positions by interrogating the objects that are part of this game object. And to get the positions, we use the get position method. So once we've built up the current game data as we did before, then we can write it out to file. Similarly, when we load, we read the details from the file into loaded game data, which is of type game data, that structure. And once we have those, we can come along and say, right, let's set the position of our objects, our private attribute objects that are part of this game object when it's running, when the program's running. So we use the set position method, and which takes a cell reference as a parameter. So we're passing this in as an argument to this method. Loaded game data has been taken from the file, and then we just get the trap position, which we stored here when we did the save. So we set it using the set position method, and we've now with the monster set awake, that didn't exist, so I had to create a set awake method in the enemy class. Okay, so we are reading info from the file, and that information includes whether the monster's awake or not, and then in the load we're calling this new method set awake to set the monster's awake status. Okay, so that's the load and save. Just to, let's see, what do we have here? So what I've done here is in the there's lots of ways to do this, but the way that I have done it is case 1 is a new game, normal game. Case 2 is a training game, and then case 3 is a new one that I've added, which is the save, and 4 is a load. And what I've done is I have split up the constructor. So originally the constructor had, let's see if we go to the, originally all you had to do was say dim my game as new game false, to say it's not a training game. And when you went down to the constructor did sort of basic setup here, set this boolean based on the parameter, randomize, because monster, the flask, and the 2 traps are put in random positions, so this randomize is run to sort of give us a different random number each time we run. But then the setup game and the play was part of the constructor, so all you had to do was new game, and then all of this lot runs. It kind of sets itself up and issues the play. Now to make the load and the save easier, what I've done is I've taken out the setup game and the play. I've taken it out of the constructor, so you need to explicitly run them after you've instantiated the object. So my game equals new game false. That just does the randomize and sets the boolean. But then I'm explicitly calling setup game here, calling the method setup game here, and calling the method play here, rather than doing them in the constructor. And it means I can create a new game here and load, rather than do a setup game. So load it from the file rather than create all the random positions for the different elements and put the player in the top left hand corner. Setup game does that, whereas I'm saying no, I want to do load instead, and then I can do play explicitly after I've done the load. And you'll see that this helps for one of the future extensions as well. So I've kind of split things up. Now the other way to do this is to pass in parameters here to say, and then within the constructor sort of decide whether you're going to do a load or not a load. And so you could pass in a new parameter to say are we loading from a file. But I prefer to do it like this. It feels a little bit more like natural OOP, that we create a new game and then we sort of set it. We have a separate setup. We say kind of set yourself up, and there could be different modes here. In fact, setup game here sets up a training game or a normal game. So you could have setup training game or setup new game. There are different ways to do it. Okay, the other thing to tell you is that I changed the play method from a subroutine to a function. So previously it was a sub, I've changed it to a function, and all I've done is at the end I've said if the player quit the game, so they weren't eaten or they didn't win because they found the flask, but they actually exited the game by pressing M, then return true to say I've deliberately exited the game. And then what that means is I'm collecting the game exited value here, and then when I loop back round, in the display menu I pass in whether I quit the previous game before it finished, and then in display menu, if I quit it without finishing, then I offer then I output the save game option. So if they lost the game or they won the game, you don't want to save it then, because it doesn't continue to play. There's nothing to do. So I'm saying only show them the save option if they exited the game before it finished. And then similarly in here, I've in the loop where the user selects whether they want to play a new game or save or load, I've got a selection here to say if the game wasn't exited, they won't see this, but they still might hit 3. They might still hit 3, in which case this would get run, and this would output there is no game to save. I won't actually demonstrate this. Maybe I'll add it another time, but I think it's better to leave it at that. That's all of the elements. An important thing is when we run round this loop, I'm saying previously we had dim my game equals new game. So it created an object within the block. See, we've got dim my game as new game false. And then when this block exits, so you move on to the next case, or you go on to the end select and then loop back round, this is destroyed because you've put this dim here. You've said that the scope is only within this bit. And so when you loop, so if you want to, let's see, how does this work? What was the issue? So I'm creating a new game. Perhaps there isn't. Okay, it might not have been necessary to do what I'm about to explain, but it becomes necessary for one of the future extensions. But what I've done, rather than having the dim here, I've put a dim at the top. So I'm saying my game is of type game class, and now I'm reusing that same object the whole time. I'm saying create me a new game, but using the existing object. And it means when I loop round, oh, I know, yeah, you do need it for this, because when I save, if it was here and I had dim my game and then I test whether the whether the game was exited, and I come out here, then it's gone. And I loop back round and say, do you want to save your game? And you say yes, but the game has gone now. That object has gone. So it's necessary to create the object up here, to declare it up here, and then here to instantiate the game class and create your object here based on the constructor, do the setup, play the game, but then loop round and back. They choose save, comes down to here, and my game is the object from the previous iteration. Okay, so it's quite involved, this extension really. Okay, hope that makes sense. And as I said before, the solution, the code is all in here. Okay, I think that will do of that extension.